Hello, this is Susan Poss. I'm going to talk to you briefly about the first factoring technique. And in order to get started, we need to know that factoring is the opposite of multiplication. So instead of saying 3 times 5 is equal to 15, we're going to be turning that process around and asking ourselves, 15 breaks down into what other numbers? So 15 equals 3 times 5. So it's going to be a reverse process. In order to find the GCF, some of you will have multiplication tables at your fingertips that you can use. Others may need to do a little prime factorization. So if we'll just see how it goes for each individual person. If we can't find anything in common, we're going to say that these are relatively prime, which means the GCF is actually equal to 1. So let me show you the process. We're going to find here the GCF of 36 and 42. So our first step here says to look for the prime factorization. So I just start breaking down 36 and continue breaking down numbers until I hit nothing but prime numbers. And I usually list these in order from smallest to greatest. The other number we're interested in is 42. And notice that the 7 is prime, so I don't further break that down. The 42 is going to be equal to 2 times 3 times 7. Again, if you multiply those back together, again, it'll bring you to 42. So now I'm looking for a list of all the factors that are in common to all terms, including variables. We don't have variables yet, but let's see what they have in common. They have in common a factor of 2, they have in common a factor of 3, and that's all they have in common. So the GCF for 36 and 42 is 6, 2 times 3. So what about finding the GCF when you have variables? The GCF of a list of variables is always the variable raised to the smallest exponent in the list. Here, so I'm looking at y to the 7th, y to the 4th, and y to the 6th. So the GCF for these is the least exponent, so it's y to the 4th. If we quickly look at these down here, p to the 7th, p to the 5th, p to the 8th, p to the 3rd, p to the 9th, q to the 2nd. So let's see here. It looks like q to the 2nd is the lowest exponent on the variable q, and p to the 7th is the lowest exponent on the variable p. So the GCF here, let's write it up here, so we can get the notation without having to rewrite all this, is p to the 7th, q to the 2nd, going again for the lowest power on each of the variables. All right, so here's a combination where we have numbers and letters, and I've already looked at the prime factorization out here for 5, 15, and 20, and as I look to see what they have in common, it looks like the only thing they have in common is the number 5. And now I'm going to look at the variables and see which is the least exponent. Looks like y to the 2nd is the least. So the GCF for this is 5y to the 2nd. All right, so I hope that's a pretty good intro there for finding the GCF.